Hello. All right, we are starting Unit 2, Entry 2 here. Oh, what I want you to do is use whatever resources your brain, just roll through, see which of the vocab words you know. There should be a word bank at the top of your notes. And then pause here and we'll go over them in a minute. Okay, so the smallest unit of an element that maintains the properties of that element is an atom. So if I were to break apart an atom into what it's made out of, protons, neutrons, and electrons, it would no longer have the same properties. So a substance that cannot be separated or broken down is simpler by chemical reaction. Means if I had a brick of gold, I can't do a chemical reaction and break it down into something else. If I broke up those atoms of gold, they would no longer be gold. We have 3 subatomic particles, sub meaning smaller atomic atom, smaller than an atom particles. We have protons, which have mass of about 1 and a positive charge in the nucleus. Electrons, which have basically no mass, have a negative charge. Those are important for bonding. Those are in the orbitals. Neutrons have no charge and they're found in the nucleus. Periods are rows, groups are columns. Metals are conductors, often shiny. Nonmetals are often brittle and poor conductors. Metalloids are kind of in the middle, and mass is the amount of matter in an element or in something. Okay, so let's talk about what we have here. So in entry 1, we learned that everything has mass is composed of matter, and there's different types and states of matter, and that all matter is made out of atoms. So what is an atom? Well, let's talk about it today. These are just some nice memes over here you get to look at. So what is an atom or atomic structure? So an atom is the smallest part of an element that maintains that element's properties. And these are the building blocks of molecules, which eventually are what we build into all the different things that we see, eat, touch, and so forth. There's a lot of different experimentation that led to the atom that we have today. And we'll talk about that a little bit next week. But eventually, what we saw is that atoms aren't the smallest thing. They can be broken up into other pieces called subatomic particles. So we thought atoms were smallest. That was the first idea of an atom by a guy named Democritus in ancient Greek, if my memory serves correctly. But then we eventually figured out that you can break up an atom into 3 parts. Because what's in an atom, you got protons, neutrons, and electrons. In the nucleus, in the center, you have neutrons and protons. So the nucleus, if you look at it, notice that's where all the mass is. There's a bunch of stuff in there, but it has a positive charge. That's the nucleus. But the around the nucleus, there's orbitals. We just describe them as rings in this Bohr model of an atom, and that's where electrons are. That's where all the size or volume of an atom comes from. Again, if you need to, pause so you can actually get the notes here. So protons and neutrons in the nucleus, mass is there. Orbitals, electrons, no mass but volume. So in general, an atom that has not been reacted has no charge, and that's because it has an equal number of protons and electrons, which we'll get to figuring out how do I know how many subatomic particles are in an atom. So the most important ones we're looking at here are protons, neutrons, and electrons. And J.J. Thomson proposed that the electrons were embedded into a ball of matter, and that was called the plum pudding model. Rutherford disproved that using a disproved the plum pudding model using a gold foil experiment, which we'll talk a little bit more about next week. So where are they located? We've already talked about this, but it's another way to look at it. So we have a cluster of protons and neutrons in the center of the nucleus. There are these orbitals or rings where electrons hang out. So the nucleus, because it has protons and neutrons, which have mass, has mass. Now electrons is, we call it a cloud, which is important for bonding, and that's where all of it is. So notice over here, this is lithium. Lithium always has 3 protons. That is the most important thing about lithium. Now its mass is 7 though, because it has 3 protons and 7 neutrons, so we call that mass number. And then it has 3 electrons because it's unreacted. Protons and electrons are the same. So every element we have the capacity to determine this. So if I was like, what element is this? You could count protons, which are the blue things, which is hard to do from this. Or we say if protons and electrons are the same, I could count. There's 2 in my first ring, then 8, so that gives me 10, and then 8 more out here, so that's 18 electrons. And element number 18 is argon. So this would be an atom of argon. So when we're looking at these things, remember protons and neutrons have mass, electrons have no mass. And remember the charge. Those are the pieces about it. I'm harping on that a lot. So what would happen if an element gained or lost a proton? This would change the element. Okay, only write what you see in red here. If it lost an electron, this happens all the time in bonding. It creates ions, and it's all about bonding. And neutrons, it doesn't change the identity, it doesn't change the charge, it just changes the mass, and it causes what we call isotopes to form. And for most elements, again, that's what we have. And this is actually the reason why we get an average atomic mass on the periodic table. That's a decimal. Because if I look at this hydrogen atom, its mass is 1, its mass is 2, its mass is 3. But if I look at the periodic table for hydrogen, the mass is 1.00794, which means almost all of my atoms of hydrogen look like this, but there's some that look like this that make it a decimal number. So how do I know how many protons, neutrons, electrons are in an atom? Well, I just have to look at the box here. If it has an overall neutral charge, my protons and electrons have to be equal. And they are both equal to atomic number. They're both equal to atomic number. So beryllium has 4 protons and 4 electrons. And atomic mass, then, if I round this to the nearest whole, 9 minus 4 tells me the number of neutrons. So for beryllium, it would be 5. We call that mass number. So atomic number is number of protons in the nucleus. It's also equal to electrons. Mass number is protons plus neutrons, and isotopes form when protons is the same, but neutrons is different between atoms. So if I know the atomic number and the mass number, I can calculate neutrons. So an example, if I had uranium-235 here, its mass number is 235. It has 92 protons like all uranium atoms. So if I subtract them 2, there's 143 neutrons in the nucleus. So all this information is given to us in element boxes on the periodic table. So not all of them look identical, like not all have these charges that it's formed. But in general, the decimal number is your average atomic mass, and you have your atomic number, which is protons and electrons, by the way, and electrons. But remember that electrons can change. Electrons can change. I should say electrons. Nice. So the average atomic mass is a weighted average, which is why it's a decimal, which I've already said, but just reinforcing it. So now what you should do is you should look at your homework here, and I've already filled in the element box. You're just filling out the information. What you're doing is labeling, are these things metals, nonmetals, or metalloids in this box. So an example, potassium, which is right here, is to the left of my staircase. So it's a metal. I'm just going to abbreviate that M. Te, on the other hand, is right on the staircase. Notice it's one of these army green colors. So that means it's a metalloid. I'm going to say MLO, metalloid. And then krypton, all the way over here on the right, that is a non-metal. Okay. Now for all of these, you have the symbol. The symbol also will tell you the atomic number and so forth. So notice that 52 is always going to be Te. 36 will always be Kr. Okay. Protons and electrons are always the same, and they're always equal to atomic number here. So 1919, 52, 52, and 36, 36. Okay, to find neutrons, I have to round this and subtract. So 39, the nearest whole is 39, so it's 39 minus 19, which gives me 20. Here it would be 127.6, that becomes 128. 128 minus 52 gives me 76. And 83.0, which would be 84, minus 36, which gives me 48 neutrons. Period and group, this is row and column, so I'll say P and G for all these. So row for potassium, oops, wrong direction. Period is row 4, column 1, so it's period 4, group 1. TE over here is row 1, 2, 3, 4, 5. And notice right here I got groups, group 16. So 5 and 16. And krypton is row 1, 2, 3, 4, column 18. So it's period 4, group 18. So you only have 3 left here, silicon, and then chlorine and cadmium as well. Okay, why don't you try those, and let me know if you have any questions.